This recording is for grade 12 math students to show what we have done using Desmos geometry. First thing we did was constructing a square. It starts by creating a segment and using parallel and perpendicular lines from this drop-down menu. When you click on the line, a running line appears. We need to attach it to both ends of our future square. Now we need to secure the same length as the side of the square by using a circle. The circle has the same radius all the way, so we actually now have 4 equal sides. There is an option to hide our construction. And now we have a perfectly looking square, which, as I say, dances and does not break. Next we used the midpoint. And I think we constructed a few other squares of smaller size using the same technique. So now I have one small square and one large. In the same manner, I can construct families of different squares, and I can color them in different colors. So at this point, let your creativity shine. Next thing we did, we constructed an equilateral triangle, I think using a starting segment and 2 circles. I think I missed my point. It is very important to arrive to a proper destination, otherwise the drawing will break. So right now I have an equilateral triangle. All sides are equal. I can go on and find a midpoint. I don't think I clicked on the midpoint. I should select midpoint. And using the same concept, I can create an equilateral triangle of a smaller, twice smaller in fact. So here's the family of equilateral triangles, and you can decorate the sides with triangles or squares the way you like. Create different shapes. And then next thing we did was a hexagon, which is a 6-sided shape. For that, I will use a helper circle, which I will recolor in red, and several other circles. So very important what I'll be doing, go from outside to inside to the center that we have. from the point of intersection to the inside, from the point of intersection to the inside, from the point of intersection to the inside. So it almost looks like a flower, but this flower gave me sides of a future hexagon. All this newly formed intersections are sides by hexagon. Now I can hide all my circles, and I can even hide the additional, the main circle. And here's my hexagon. I can repeat this construction and I can build circles, squares, triangles on each side, create more and more geometric shapes. Octagon will be another option. Using square, we will be able to build an octagon. Next, we also did tangent circles. For tangent circles, we need the concept of angle bisect. For that reason, I use two rays. And angle bisect is a ray that cuts it in half, but I cannot place it anywhere I want. There should be a specific method for it. Again, using circles, I will construct angle bisect. And I realize that I'm showing it and it could be fast, but feel free to pause this. And why can I not move anything? Yeah, I should be able to move. And as you see, my bisect, which is this line, let it be orange line, always cuts my angle in half. So I think this dot, several dots are not needed. This dot can be hidden, this dot can be hidden, and this dot can be hidden. It's always a good idea to hide things we don't need. So here's the important things. Now, if we want to inscribe a circle inside this angle, here's what we want to do. Let's suppose the circle will start here from the red point. And we want the circle to touch. Sorry, we want the circle to touch. It is not enough. It is not enough to just draw it, because it will run out eventually. We need to draw it very specifically. So from this point, that is the center of a circle, we'll construct a perpendicular line to the lower arm of the angle. So choose perpendicular to the lower arm going through the new center of a circle. And then we get the circle specifically to the point of intersection. I'll just mark the point of intersection. I'll mark it in red. So the circle will be red to red. From red to red. Try to recolor circle red. So now my red circle is definitely 100% always inside. It's not gonna run away. It will be tangent to the angle. Tangent meaning touching, not crossing, but touching specifically in one point. So those are the things we've done in class. And the last thing was cutting a segment into many pieces, basically as many as you want. So this is the segment, and say we want to cut it 7 pieces. So we draw an auxiliary ray and we create 7 circles. Every time we draw a circle, we use the points that we just created. They naturally stick to each other. 1, 2, 3, 4, 5, 6, 7. I created 7 circles. 7 circles gave me 7 points. Interestingly enough, I don't need circles anymore. I can hide them. I only need the points that they created for me, the distances that they measured for me. Did I unhide them all? I want to hide them. So yes, I only need the 7 equal pieces. This dot, I'll recolor it in black. It's the dot that I can drag. But then the 7 pieces, 1, 2, 3, 4, 5, 6, 7. So now what I want to do, I want to connect the ends, sort of close it. And this will be my reference point line, reference segment. So I'll mark it red. Now I'll be creating parallel lines, parallel to the red one, going through each of these points. Ready? Parallel to the red, going through the point, parallel to the red, going through the point, parallel to the red. How many times? 7 times? Because I think that's 6 times, because that's how many pieces we wanted to cut. If we cut 6 times, do we get 7 pieces? What do we want? Obviously, we need those points of intersection. Parallel lines for us, no longer needed. But because our lower ray had equal pieces cut, the upper ray will also have equal pieces cut. Secret geometry method. We technically don't even need the lower one. We can hide this as well. So nobody will know how we constructed a segment that has 7 equal parts. That's it. It's now a secret. Later, we construct another segment attached, and then we connect them in beautiful shapes. Even if we connect them in arcs and circles, we create different geometrical shapes. So those are some skills that we have achieved in Foundations 12. Thank you for watching.